The contract to work was signed, staff were hired, in some cases we relocated some people from Newmont in Australia, other cases we went out and hired on the open market, and we set up 3 separate general reconnaissance teams in each of the 3 contracts of work, put a senior bloke in charge of each of them, and did what in the contractor work system that Indonesia operated, did what was called the general survey. I mean, it was a very broad-spaced geological mapping program, stream sediment, minus 80 mesh stream sediment sampling program, careful float mapping, and the idea, I said to all my guys before we started, that here is what we're looking for. Yes, we're looking for epithermal gold deposits. Yes, we're also looking for gold deposits that might have copper in them. But you know, Indonesia was known for its nickel as well, so we're going to assay every sample for a wider spectrum of minerals, just because we might serendipitously find something other than what we're looking for. But what I said to them was we needed a sufficient density of sample coverage so that the only time we'd be coming back would be to follow up an anomaly. We also implemented one of the first BLEG sampling programs. The bulk BLEG extractable gold technology was relatively new.
Developed in Australia?
Developed in Australia. We'd done enough BLEG sampling ourselves, that is Newmont had in Australia, to know that it absolutely worked, even though there were sceptics of the technology. But the real beauty of it was that at every sample site in these remote, wild and rugged bush drainages, we took conventional minus 80 mesh stream silt sample, we did a panned concentrate sample, and we took representative samples of the float. And then we took a 5 to 10 kilogram BLEG sample at every site. So you would be to each sample site for 1 or 2, sometimes 3 hours, with a team of field assistants and panners, people that knew how to collect BLEG samples and sieve your stream sediments for minus 80. So we ended up with 4 different samples from each sample site and tried to get no more than about 8 square kilometres of catchment, if you like, in each sample. So you'd walk up the main streams, you'd go up the bigger side streams and the tributaries for all of those, and at the end of the survey we had comprehensive coverage all the way up to the spine of the ranges, to the point where if there were any geochemical anomalies from any of those samples, we had the rocks from hand samples to go back to, we had the pan concentrates that we could go back and have a closer look, and we had geochemistry from the BLEG samples and the minus 80 mesh to tell us whether there was anything there or not. In each of the 3 contracts of work, that general survey period took between 12 and 18 months and employed lots of people in very primitive bush camps on some fairly adventurous means of getting in and out. No helicopters, no roads, everything on foot, sometimes by canoe around the coast, sometimes surfing across the reef in an outrigger canoe, surfing up on a beach where there hadn't been too many footprints by anybody, largely uninhabited terrain in the case of Sumbawa. And in the end, we ended up with a database of geochemical sampling that showed anomalies all over the place.